Here we have a circuit power question. So we have a circuit with three different types of elements. You have two batteries. And so the total resistance is 50 ohms and the EMF at 1. So the first battery EMF is 10 volts and the second one is 5 volts. And so determine the current through and the potential difference across each resistor, and at what rate is energy dissipated in each resistor, what is the power of each battery, and is energy used by or supplied by each battery. Okay, so we know the junction rule and the loop rule. The junction rule notes the current going in is the current going out, and the loop rule is the total EMF plus the total voltage is equal to 0. And so we have the current of the left plus the current to the center plus the current of the right is equal to 0. And we're able to use that we're able to rearrange these equations to find the total amps between each resistor, the total amps. So the current of the left, we rearrange this equation. We're able to find the negative 5.0 volts plus 10 volts divided by the total ohms is 0.10 ohms. 0.10 amps. And the current of the right, we rearrange this equation again. We get 0.5 volts divided by 50 ohms plus 50 ohms plus 50 ohms is equal to negative 0.033 amps. And the same thing, the current in the center is negative 0.10 amps plus 0.033 amps is equal to 0.067 amps. Basically, we were just rearranging this equation, and this is just derivations of this equation, and just solving the current flowing through each portion. So from here to here, here to here, and here to here. And so we're able to find 0.10 amps, 0.033 amps. Oh, that's a negative. And where is it? Oh, negative 0.067 amps. And you can determine the current across any resistor as the change in potential difference is equal to the current left resistance is 0.10 amps times 50 ohms is equal to 0.5 voltage, which is the EMF of the second one. So our potential difference is all these summed up. So it's 0.033 amps times the 50 ohms, which is 1.7 volts for all of the resistors. And so for question B, at what rate is energy dissipated in each resistor? We know the equation to power, which is power is equal to current squared times the resistance. So the current at of the left is 0.10 amps squared times total resistance, which is 0.50 watts. And then the current at the right is 0.033 amps squared times 50 amps, which is 0.056 watts. And then what is the power of each battery, and is energy used by or supplied by each battery? So we were able to find an EMF and the total power. And so we were able to find the power rate. So 10 volts times 0.10 amps. And this is the EMF of the first battery. And this is the EMF of... No, this is not the EMF. This is the amps. I'm sorry. This is to find the total watts. So yes, this is 0.067 amps times 5.0 volts is equal to, I just switched these around, I'm sorry, so 0.33 watts. So this is the power weight.